ever pondered on how the state of our planet could possibly be influenced by quantum physics? We often think of quantum physics as a realm far removed from our everyday lives. It's the world of the subatomic, the strange, the paradoxical. But what if I told you that this seemingly distant realm might hold the key to understanding and perhaps even addressing the environmental challenges we face today? This is the idea behind quantum environmentalism, a groundbreaking approach that marries the principles of quantum science with the ethos of environmental stewardship. It's a fresh perspective, one that recognizes the complex interplay between the smallest particles in the universe and the grandeur of our global ecosystems. At the heart of this approach is the understanding that everything in our world, from the tiniest atom to the largest ocean, is interconnected. Quantum physics teaches us that particles can be entangled, influencing each other instantaneously across vast distances. In a similar vein, the actions we take in one part of the world can have far-reaching impacts on the environment elsewhere. This realization compels us to rethink our relationship with the Earth. It encourages us to approach environmental issues not as isolated problems, but as symptoms of an interconnected system out of balance. So, how does this translate into action? Well, quantum environmentalism proposes that we can use the principles of quantum physics to develop innovative solutions to environmental problems. It suggests that we can leverage the strange, counterintuitive nature of the quantum world to better understand and manage our planet's ecosystems. It is a call to arms, urging us to become stewards of the quantum Earth. It's a challenge, inviting us to harness the power of quantum science to safeguard our planet for future generations. And at the heart of this quantum environmentalism lies the McGinty Equation. So, what exactly is this McGinty Equation, you might ask? Well, let's dive into the intriguing world of quantum environmentalism. The McGinty Equation, or MEQ, is a key player in advancing environmental research and conservation. It's a bit like a mathematical superpower, giving us the ability to model complex natural phenomena. But what does it entail? Consider this. The MEQ has two major components. The first one, called PSQFT, represents the solution of the free quantum field theory. Think of it as the basic building block of our quantum reality. It's a bit like the DNA of the physical world, detailing how particles and fields interact and evolve over time. The second part of the equation, fractal XTDMQQS, is the fractal potential term. This is where things get really fascinating. This term describes a self-similar fractal structure, which is a pattern that repeats itself at different scales. If you've ever admired the intricate spirals of a seashell or the branching structure of a tree, you've witnessed fractal patterns in nature. But the McGinty equation goes a step further. It represents the perturbative effects of gravity on the quantum field. This allows us to understand how gravity, one of the fundamental forces of nature, impacts the quantum realm. It's like adding another layer of complexity to our understanding of the environment. Now, why is this important? Well, this equation aids in modeling climate change and ecosystem dynamics. It provides a framework to understand and predict the complex interactions within our planet. And it doesn't stop there. The potential applications of the MEQ extend to environmental monitoring and pollution control, helping us to keep a closer eye on the health of our planet. So, the McGinty equation is not just a mathematical expression, it's a tool for understanding our environment, a conduit for quantum-inspired approaches to sustainability and eco-consciousness. It empowers us all to become stewards of the quantum Earth. The McGinty equation is not just a mathematical expression, but a tool for understanding our environment. How does this equation relate to environmental conservation, you might ask? Well, the McGinty equation, or MEQ as it's more commonly known, is more than just a mathematical expression. It's a tool, a lens through which we can examine and understand our planet in a more profound way. It's not just about the numbers. It's about what those numbers represent, the complex, interwoven dynamics of our planet's climate and ecosystems. Picture our planet as a vast, intricate mechanism with countless gears and cogs all turning in sync. Each gear represents an aspect of our environment, from the smallest microorganism to the largest mountain range. The MEQ helps us understand how these gears fit together, how they affect one another, and how changes in one can ripple out to impact the whole system. By using the MEQ, we can model climate change more accurately, giving us a clearer picture of how our actions today will affect the world of tomorrow. It's like having a crystal ball that can show us the potential consequences of our actions, allowing us to make more informed decisions about how we treat our environment. But the MEQ doesn't just help us understand the problem. It also points us towards the solution. It provides us with a roadmap for environmental monitoring and pollution control. By applying the principles of quantum physics to our understanding of the environment, we can develop more effective strategies for conservation. We can predict where pollution is likely to spread, identify at-risk ecosystems before they reach a critical state, and implement targeted interventions to protect and restore our planet. In essence, the MEQ is a bridge between two worlds, the abstract realm of quantum physics and the tangible reality of environmental conservation. It's a tool that allows us to apply the principles of the quantum realm to our efforts to preserve and protect our planet. So, you see, the MEQ isn't just a collection of symbols and numbers. It's a key to unlocking a better, more sustainable future. The McGinty Equation opens a new pathway for sustainable solutions. But what can we, as individuals, do with this information? You might be thinking, well, the answer lies in quantum-inspired stewardship, an approach that encourages us to harness the power of the McGinty Equation in our everyday lives. It's not just the realm of scientists and researchers. This equation, this tool, is our passport to a sustainable future, a future where we become co-creators of a vibrant, thriving planet. Quantum-inspired stewardship is about understanding the interconnectedness of everything. It's about realizing that we're not separate from the environment. We're part of it. Each action we take, no matter how small, has a ripple effect. And the McGinty Equation, with its quantum field theory and fractal potential, helps us visualize these ripples, these connections. Think of it this way. When we make eco-conscious choices, we're not just helping our immediate surroundings. We're influencing the whole ecosystem, the entire quantum field. It's like throwing a pebble into a pond. The ripples spread far and wide. That's the power of quantum-inspired stewardship. By incorporating this understanding into our daily lives, we can become more mindful of our actions and their impacts. We can make choices that benefit not just us, but the entire planet. Whether it's reducing waste, conserving water, or supporting renewable energy, each step we take in the spirit of quantum stewardship is a step towards a healthier, more sustainable Earth. And it isn't just about individual actions. Quantum-inspired stewardship also highlights the importance of collective action. It encourages us to work together, to share our knowledge and resources for the greater good. After all, we're all part of this quantum Earth, and together we can make a difference. So let's embrace this new approach. Let's become quantum stewards, using the insights from the McGinty Equation to guide our decisions and actions. Let's understand the ripples we create and use them to steer us towards a more sustainable future. It's time to embrace our role in the quantum Earth, for only then can we truly protect and preserve our planet.